Hi, I'm John Harris, Solution Development Manager, Dell Data Center at MoreDirect. I'm going to provide a quick overview of Dell's XC Series, and then we're going to take a look at some of the key features using an animated whiteboard. On February 25th, Dell announced the newest generation of their XC Series, which is powered by Nutanix, the fastest growing infrastructure technology of the decade. Nutanix is a commercialized version of the infrastructure technology which is running under Google and Facebook. Dramatically increases IOPS by placing hot data on flash in the node of the virtual machine which most frequently accesses it, while still sharing that data with other nodes within the cluster. You can kind of think of it as a traditional SAN that also runs a hypervisor in virtual machines. However, with a traditional SAN, your IT budget can be disrupted with some fairly significant financial outlays as you run out of capacity or need software upgrades. Okay. In contrast, Nutanix grows one node at a time as your data and compute needs grow. So Nutanix also comes pre-configured with either Hyper-V or VMware, and you can literally start running virtual machines on it within 30 to 40 minutes of the time it's delivered to you. It's a best-of-breed solution, enabling you to reduce your power consumption through Dell's Fresh Air initiative and continue using familiar management tools like iDRAC and OpenManage. It's based on Dell's PowerEdge servers, which are the #1 selling server in North America, and it's supported with Dell's global support team. Let's take a look now at some of the key features.
In a traditional virtualized environment, hypervisors allow multiple virtual machines to run on a single physical host, and the hypervisor handles all I/O operations in the same way a physical host does. A centralized storage array, such as a SAN or NAS, provides shared storage for all of the VMs. In contrast, Hyper-Converged architecture uses local attached storage to provide faster performance and greater flexibility. Each node in an XC cluster includes flash-based storage to deliver massive IOPS for high performance, as well as hard disk drives for low-cost, high-capacity storage. XC implements all control logic as a software-based service. A virtual storage controller runs on each node of the cluster, improving scalability and resilience while preventing performance bottlenecks. With storage and control logic now local to the guest VMs, there's no more need for centralized storage or dedicated storage networks. The Nutanix distributed file system aggregates local storage across all nodes, creating a single storage pool that can be partitioned into one or more data stores. These data stores are then presented to the hypervisor using the standard NFS protocol to provide storage for all hosted VMs. Because the hypervisor communicates to the Nutanix software exactly as it would a traditional storage array, there is zero change to the virtual environment. VMs are provisioned and managed as before, but without having to configure LUNs, volumes, or RAID groups. Let's take a look at how Nutanix manages a typical write operation. When a guest VM needs to write data, its request is passed to the Nutanix controller, which then executes the write to local flash storage. It's also important to fully protect data so that it is always available, even if a node fails. To ensure the strongest protection, data is replicated synchronously across multiple nodes. For a typical read operation, requests are served by local storage resources. Keeping data local to the VM provides the fastest possible performance. That means for the majority of read requests, data never traverses the network. With many enterprise workloads, the older the data, the less frequently it's requested. When data becomes cold over time, it is migrated from flash memory to more economical hard disk storage. However, if that cold data at any point becomes hot again, meaning it is requested more frequently by a VM, Nutanix automatically promotes the data back into flash for the fastest possible performance. So what happens if there's a node failure? Nutanix supports standard high availability capability, such as VMware's high availability, so a VM will automatically start on another node. If that VM then needs to read or write data, it sends its request to the local Nutanix controller. If the data being read is not local, the controller determines where replica data has been placed and forwards the request to the correct Nutanix controller. The data is then sent back to the local Nutanix controller over a standard Ethernet network. The local Nutanix controller passes the data to the VM through the hypervisor and stores it locally for future access. At the same time, the Nutanix software once again replicates the data throughout the cluster in order to return the full cluster system to a fault-tolerant state. Each XC node runs independently and leverages the Nutanix distributed software architecture to create a completely unified cluster. The XC63010 web-scale converged appliance supports 3 independent nodes and only 3U of total rack space. For more cluster capacity, 1U nodes can be added seamlessly, one at a time, with zero downtime. You can start small and easily expand to achieve truly massive scale. It's perfect for compute and performance-intensive VDI, test and development, private cloud, and server virtualization. Dell also offers the XC730 XD series. The 12 is designed for storage-heavy Microsoft Exchange, SharePoint data warehouse, and big data, along with the XC730XD24 for performance-intensive SQL and Oracle online transaction processing. Well, again, I'm John Harris, and here's my phone number and email.